Hey everyone, welcome to Geometry, Section 5.1, Perpendicular and Angle Bisectors. Now, Chapter 5 is all about special segments and lines in triangles. Some of these things we've talked about before, but we're going to look at them in a new way. Okay? So this section is all about perpendicular bisectors and angle bisectors. So by the end of this lesson, you should be able to understand and use the perpendicular bisector theorem and its converse, write the equation of a perpendicular bisector, and understand and use the angle bisector theorem and its converse. So let's go ahead and hop right in. So we've talked about a perpendicular bisector before. We start off here in this example with segment AB. And so a perpendicular bisector does two things. It's perpendicular because it makes a 90-degree angle. It's also a bisector because when it makes the 90-degree angle, it cuts segment AB into two equal pieces. So those are the two parts that makes it a perpendicular bisector. Cuts it in half, makes it 90 degrees. An angle bisector we've also talked about. An angle bisector takes an angle, cuts it right in half. So you know that however many degrees is in A up at the top, that's how many degrees there are in B down at the bottom. So we're going to take a look at these inside a triangle. So here we have an example of a perpendicular bisector and an angle bisector. Let's put the angle bisector away. We'll get back to that in just a second. But here we have a segment. This blue line is our original segment. And the skinny black line, that goes right through it, and it creates a 90-degree angle. So you can see that no matter what I do with this original segment, that skinny black line always goes right through the center of it and always makes a 90-degree angle with it. So the perpendicular bisector theorem says any point that's on this perpendicular bisector will be equidistant from the two endpoints. Basically, that means the distance from this point down to the endpoint will be the same as this point down to the other endpoint. And you can see that I've already measured these, and that proves to be true. No matter where I move it, those two distances are going to be the exact same. So go ahead and get out your notes packet that I gave you, and let's go ahead and follow along with these notes. All right. So when a point is the same distance from two or more objects, the point is said to be, we just said this word, equidistant. And it's exactly what it sounds like. It's the same distance away from two different objects. So as we said before, if you've got a point that's on this perpendicular bisector, it's going to be the same distance from the two endpoints. So you could say that point C to point A is the same distance as point C to point B. So let's take a look at a few of these examples. So it says find each measure. Well, if we take a look at the diagram, there's evidence that this line is the perpendicular bisector. I've got the two congruent marks, and I've got the 90-degree angle. So point N, which is on the perpendicular bisector, has to be the same distance from each endpoint. So since the distance from N to L is 2.6, that means the distance from N to M is also going to be 2.6. And these numbers are really tiny to read in on the screen, so if I get something wrong, you'll have to forgive me on that one. Let's take a look at question number 2. So on this one, I see that's perpendicular, and I also see that point A is the same distance from B as it is from C. So that tells me that point A is on the perpendicular bisector. So how does that help me find BC? Well, because if DC is 12, then I know that BD is also 12. And if they want to know what the length of BC is, just take the 12 and 12 and add them up. So be careful on that one. I've seen students in the past say, well, it has to be 12 because that's 12. Well, BD is 12, but they were asking for BC, the whole thing. Let's take a look at example 3. So here, I have evidence that this is a perpendicular bisector, and so point U is on that perpendicular bisector. So the equation I can set up is going to be 7x minus 17 equals 3x plus 9. Go ahead and work that out. We get 26 divided by 4. So 26 divided by 4 is 6.5. And there we go. We found x. But it's not asking us to find x. It's asking us to find tu. So I've got to go ahead and plug that back in. So 7 times 6.5 minus 17. And I believe that gives us 28.5. So that's my answer on that one, 28.5. So let's take a look at question number 4. Now this one's going to be a little bit different. It says, write the equation in slope-intercept form for the perpendicular bisector of the segment with the endpoints -1, 6, and 3, 4. So what I've done, just to give us a little bit more room, is I've copied this onto a separate piece of paper, and that'll give me a lot more space to work here. I've also put a couple formulas that are going to be helpful to us in order to do this. So if you recall, back in chapter 4, I gave you some videos to watch over how to do like y equals mx plus b and other stuff regarding lines. And the main idea I wanted you to get is that if you want to write the equation of a line, you have to have a slope and a point. Well, right here, I've got 2 points, and I need to find the equation of a line perpendicular to this one. So if I want a slope and a point, first thing I'm going to do is I'm going to find a point. I'm going to use this midpoint in order to bisect this angle, or this segment. So if I take the 2 endpoints, let me go ahead and get this going. So I average up the 2 x's, so -1 plus 3 over 2, and average up the y's, so 6 plus 4 over 2. So that makes 2 over 2, which is 1, and 10 over 2, which is 5. So the midpoint of this segment is 1, 5. So let's see if this makes sense. Go over 1, up 5. Sure enough, right in the middle. So now I've got a point that's on the perpendicular bisector. Now I need to know the slope. Well, I can use this formula right here and find the slope. I can do 4 minus 6 over 3 minus -1. Or I could just take a look at the graph. Going from one point to another, it looks like I go down 1 and forward 2. So my slope is -1/2. But that's the slope of my current line. A line perpendicular to that is going to have a different slope. The slope is going to be the opposite reciprocal. So for my new slope, let's get a new color. My new slope, I'm going to flip it, turn it into a 2, and flip it from a negative to a positive. So my new slope is +2. So I'm going to take the point 1, 5 and the slope of 2, and I'm going to make the equation. So just for kicks, I'm going to use the point slope form. So I get y minus 5 equals 2 times x minus 1. Distribute. Add 5 to both sides. So there's my equation, y equals 2x plus 3. I'll write that up here for reference. And now I'm going to graph it just to verify that it looks like the perpendicular bisector. So I go up 3, and then up 2 and over 1, up 2 and over 1. I can do the opposites, go down 2 and backwards 1. And then make my line. And sure enough, that looks like a perpendicular bisector. So let's recap everything that we just did. You use the midpoint formula to find the midpoint. Then you use the slope formula to find your current slope. Do the opposite reciprocal. And now you've got your new slope. And then just plug it into this formula and you've got your equation. Okay? So that's the heads up on perpendicular bisectors. Let's take a look at angle bisectors next. All right, back to this screen. Let's get rid of our perpendicular bisector and let's open up our angle bisector. So this big blue angle just got bisected. So you can see that no matter what I do to the angle, that skinny black line's going right through the middle of it. And the idea of the angle bisector theorem is that if you have a point on the angle bisector, which I do, that point is going to be equidistant from the two sides. So you see, no matter which way I move it, I measure the distance from that point to the side, and it's always the same. And then the converse of that is if I have a point in the middle of a triangle or in the middle of an angle, and it's the same distance from all the sides, then I know it's on the angle bisector. So let's get back to the notes and do a few problems. All right, so question 5. I've got the clue that this is an angle bisector because I've got those little congruent arcs there at angle A. And so I know that any point on this middle line is going to be the same distance from either side. So I know the distance from point C to D is the same as the distance from C to B. So if the distance from C to B is 7.2, then I know that B to C is also going to be 7.2. If you take a look at question number 6, it says the measure of angle EFG, which is this whole big angle, is 50 degrees. And then there's evidence here that point H is the same distance from the two sides. So what they're trying to get you to see here is that point H is on the angle bisector. So if that's the case, then the measure EFH is half as much as the original angle. So I can say the measure of angle EFH is 25 degrees. Next question here. So I have the evidence that point M is on the angle bisector because it's the same distance from point J as it is to point L. So because it's the same distance from both sides, it's on the angle bisector. So I know that this half of the angle is the same as the other half of the angle. So I can write that 3A plus 20 equals 2A plus 26. Work a little bit out of your algebra magic and you should get A equals 6. But it doesn't ask what A is. It asks for the measure of angle MKL. So MKL is over here. So I'll have to plug in the 6 to that. So 2 times 6 is 12. 12 plus 26 is 38 degrees. So the measure of angle MKL is 38. So that's what you need to know about an angle bisector, is that any point on the angle bisector is the same distance from the two sides. If a point is the same distance from two sides, it's on the angle bisector. If you guys have any questions, please feel free to email me or ask me in class. And hopefully Chapter 5 won't be too bad for you. You guys have a good one, and I'll see you real soon.